Assalamu alaikum wa rahmatullahi wa barakatuh. Alhamdulillah. Today I'm blessed. Another day of my life to live into 28th of Rabiul Awal 1442, 14 of November 2020. Thank you, YouTube. Thank you, all my channel's subscribers and viewers and those who comment with some input and positivity, a lot of information thus far. Thank you very much. Before we proceed, please implore ourselves not to watch this video when you are already in a mosque for the Friday prayers, especially when Khatib is reciting a khutbah, and also if you're in any religious events, religious seminar, lessons by all the scholars, please stop watching this video. Thank you very much for that cooperation. Today, we are going to look into another attempt for me to link safety, health, and environment concern. And this topic is on effluent treatment plants. I believe if you are in Malaysia and you are a competent person for the industrial effluent treatment, it could be physical treatment competency, biological effluent treatment, or chemical physical treatment competencies. Welcome to the club. All these are multitasking for the new generation of Malaysians who are competent persons in a few areas. Also come maintenance engineer, maybe come internal auditor, come EMS, ISO 14001 steering committee, come many other things. So I hope in view of your compact or rather integrated responsibilities that you are having on your shoulders right now, this video would help alleviate some of the pain of those loads of responsibilities that you're carrying out. So I am attempting to link safety, health, and environmental concerns from this particular activity, which is effluent treatment, and we shall then focus into the environmental aspects, impacts, and what is required as far as the environmental management system ISO 14001 is concerned. All right, let's take a look. What have we here? As usual, I'll display a picture. This picture is a segment of the chemical process of a industrial effluent treatment plant taken many years ago, and this is actually one of its coagulation and flocculation chamber, and you can see that there's a what they call coagulant drum with an automatic pH triggered pump that they call dosing pump. All right, we are going to discuss all the details, but I'll give you an example. Now, our concern, let us begin with supposed to be safety first, but since I'm not the expert as far as safety and health is concerned, please allow me to begin with environment. Okay, I am focusing here. We will pick one environmental aspect to discuss. Let us begin with this environmental aspect. Well, positively, we'll take a look at treated effluent. Now, in this country where I am, Malaysia, we call it treated effluent. Raw effluent is in books, we call it influent, but here we call it raw effluent, untreated effluent, and it gets into this system called IETS in Malaysia today, which is Industrial Effluent Treatment System, to conjure to the new regulation, Environmental Quality Industrial Effluent Regulations 2009. Yeah, okay. And for that reason, we call it industrial effluent treatment system, and the people who are competent in this, they call it competent person in industrial effluent treatment system. Now, begin with treated effluent. How does, imagine, we're not talking about raw effluent. It has gone through the array, all the unit processes in an industrial effluent treatment system. Raw effluent is being treated. Once it has completed the treatment, it is monitored for its final quality. When it has met the regulatory permits standards, discharge standards, it is allowed to be discharged from the system. That is in the form of treated effluent. So here goes treated effluent. How does it affect safety? Okay, as far as treated effluent is concerned, all this activity of treatment occur or takes place in, as you can see, civil structures, tanks full of water. Although it's treated effluent in the final tank, the potential hazard is probably the deep tanks itself. The tank itself is a potential hazard because there are cases of people who fell. In fact, animals fell into this. Some of the tanks are deep because of constraint in space. They can't afford to have an aeration tank which is large and shallow. So instead, they have to build smaller, deeper tanks, and the aeration is assisted with a diffuser due to the space constraint in many cases, or perhaps in management term, space management. Okay, so they have got these deep water tanks which are actually potential hazard, and we have got around the tanks, because this system is electrical powered, they have got a lot of electrical wiring, conduit circuits, consisting of electrical wirings of different types and sizes, connectors, and they are all electrical powered, and this system uses a lot of electrical energy, and that is another potential hazard. On top of that, the treatment of this system uses certain kinds of chemical. It could be inorganic chemicals like ferric chloride or aluminum sulfate, and it could be involving some other types of chemicals in terms of coagulants and flocculant aids, such as cationic or polyionic or polyelectrolytes, sort of polymer coagulant, which is not inorganic. Okay, and these chemicals do pose, of course, uh, obvious hazard or obvious potential hazard to human handler, the treatment systems operators, and they have got to use PPE when handling these chemicals. And on top of that, the content, especially in the biological part of the system, which deploy microbes to do biological degradation of especially organics. And these microbes could be of different strains when they are, even though they are aerobic, for instance, in an aeration tank, these microbes are alive, and some of them could have potential pathogen, could be a potential pathogens, pathogenis, pathogenicity, blah, blah, blah. Okay, right. That would be a health hazard then. That is a potential hazard that could affect health. So in that sense, safety potential hazard has a direct so-called relationship or direct impact to health, especially of the workers. And it, as I have mentioned, there is a potential risk of having injury while at work. As you could see, some of the structures is not that ergonomics. Well, at least this plant is okay, but there are some sharp edges, and the walking path for personnel around the area, I think, has an evident, obvious potential hazard, right? And people can have a misstep, especially when you are already an expert. You could think that you could walk around these structures blindfolded because you have been there working for 10 years. That is where most of accident originated. Correct me if I'm wrong, especially when people have done this work in a routine manner. Then one of those days something went wrong and we get injury. And also, when we are dealing with biological treatment system, there are all these pathogens, disease-causing microbes, pathogenic microbial populations. Some are in the water, some could be in the form of spores, or on top of the aeration, could be in the form of volatile mist, and they are in airborne and becomes airborne microbes. These are all potential uh, what I call risk to human health in terms of getting infection from the intrusion of these microbes into the human body, and the human body has got to fight, has got to repel the invasion of microbes in the body medically. And some of these vapors can be intoxicating and could intoxicate workers. That would be a health concern. And when these workers, operators of the system, is in such a manner, he or she might not be able to perform the work well and get ill and get sick, and he or she has got to be referred to the perhaps factory medical facility and get attention and be administered with some form of medicines, and maybe if it's injury, address all the wounds, and all this would lead to the generation of so-called medical waste, which could be urophoric, or could be pathogenic, and well, we can classify them as medical waste, where in Malaysia it is a scheduled waste and would lead to an environmental impact of air pollution if this waste gets to medical waste incinerator. Okay, and that would normally happen here, and that's the link between in that line between environment, safety, and health. But as far as the reverse order is concerned, similarly, the treated effluent, well, when we talk about treated effluent, it could be a clean effluent, but nonetheless, it's not 100% free of biological component. The BOD might still be around 20-50 milligram per liter, meaning there is a potential viable bacterial cells still in the water. Is not absolute zero. There is still potential microbes in the treated water that would still impact human health. And for that reason, the worker over prolonged exposure maybe has allowed the infection to be uh, occurring over time, and he might have some symptoms of sickness, or probably nausea, or probably, discomfort, and due to that might not be able to perform his work according to the desired methodology or SOP. So he might alleviate some potential hazard, and might have caused uh, his inability to operate this treatment system in the correct manner while he's working, maybe not able to check the pH on time, not able to set the correct coagulant dosing rate, and that would lead to the release of inadequate treatment of treated effluent and release it to the environment, and that would cause some kind of environmental pollution, namely water pollution. Okay, so that's the link, one way or the other. It's a circle, and it's reversible, literally. So in the next part, let us take a look at the environmental management system, ISO 14001 version 2015. Can you still remember the definition of environmental management system? What does environmental management system manage? Can you remember? So let us remind ourselves that Environmental Management System ISO 14001 version 2015 is about managing environmental aspects. So what is environmental aspects? Environmental aspects, as I mentioned in the first slide, is anything, is an item, substance, matter, not process. Environmental aspect is anything that interacts or can interact with the environment. Remember that? And environmental management system is managing all these environmental aspects by fulfilling compliance obligation and addressing risk and opportunities. So in other words, this is an effluent treatment system. We are supposed to manage what? All this raw effluent, and when the effluent is in each unit process, we got to manage it. How? By having the proper operating procedure for that individual unit processes to treat those respective phases of effluent from one unit processes to another. That SOP is an environmental operational procedure. Okay, so now let's take a look at this particular environmental aspect. Our good friend, treated effluent. Cleaner water. I'm saying cleaner water, not really clean water. It's not like the ambient, naturally occurring mineral water that we get from our aquifer. It's different. This is still containing some level of biological oxygen demand, chemical oxygen demand, whereby there is some permitted amount of trace inorganics, metals, could be salts, nutrients, even nitrates, phosphate, etc. So never mind that. We'll talk about it later, maybe. All right, treated effluent. What the question is, this is an environmental aspect. Why? Because it can interact with the environment. How does it interact with the environment, and what is its associated environmental impact? So we got to look here. This particular aspect is an output aspects. So we got to use our knowledge on life cycle assessment or life cycle perspective. We got to look at this treated effluent from its life cycle perspective. It is a treated effluent and it is an output aspect. So we have got to look at the downstream, along the downstream of its life cycle. What happened to the treated effluents next? It will be surpassing the final discharge point of this particular treatment plant, and it will bring itself flowing into the nearby ditches and flowing into streams and rivers, thereby flowing through what is called land-based water body, or in this country it is legally called inland water bodies, thereby with that still uh, containing, with the treated effluent still containing substantial, of course, permitted level of BOD and COD and trace inorganics and etc., plus the flow rate that it enters this water body, it will over time causes a certain level of pollution load as a new load into an existing stream or river. Thereby, in other words, it is a foreign matter now. Although meeting the permitted standard, it still is an additional foreign matter that enters all this water body, thereby causing what we call water pollution. Remember, pollution is due to loading. Loading is concentration multiplied by flow rate, and we get of mass of pollutants, in this case mass of COD, mass of heavy metals, mass of microbes, suspended solids, in terms of perhaps kilogram per hour, continuously entering the natural resources of our rivers. Despite passing the standard, it still poses threat to the environment in terms of pollution. Think about it. And with that load, new members of foreign matters into the existing natural water body, the nutrients, maybe additional nitrates or ammonium or heavy metals that over time, due to the load, remember the load, would pose some form of threats to the aquatic lives of the river, the stream, or the estuarine, or the lakes. And you may have an effect, perhaps a bloom, a high growth of certain algae causing some algal bloom, a kind of eutrophication due to the excess presence of nitrates, perhaps phosphates, perhaps sulfates, and all this. Or it could be a heavy metal load over time, and that would be toxic to aquatic lives, especially uh, planktons, phytoplanktons, protozoans, and all other lower trophic levels of the ecological system. Okay, the biotic part of that water body, and that has caused definitely some diversion, if not imbalance, in the ecological cycles. The food chain might have get distorted over time, and over time, over prolonged time, and we do not know. Eventually, we have some level of pollution, and suddenly certain species of fish extinct certain species of aquatic plants becomes extinct, and that would cause some other problems. A bloom of certain other types of aquatic lives. Excess of certain things is not good. The environment has got to maintain all this population in the right proportion, the right figure, a kind of ecological stoichiometry to balance out all their ecological equations. And that what I have said is probably a kind of hydrological imbalance. The river in its natural being carries a certain load of water from the spring water from a mountain or hill coming from bedrock, and that water flows downstream in a certain amount per unit time, enough to sustain life in the entire ecological system from the spring right up to river mouth. And it carries with it minerals coming from rocks and also inorganics, but in its natural form, naturally occurring organics, enough for the designed ecosystem. Nonetheless, you and me, we have development and we construct industrial areas, and we have used water from sources, and we treat the water for environmental purpose, meeting environmental standards, but we cause an additional flow of water into the existing streams and rivers. So the water balance there is disrupted. There's an imbalance. The ecology in that existing system is only able to cope with what it has, but now you have got additional load of water body. It's like drinking excessive water every day. If you're required to drink 2 liters of water a day, now you're drinking 5 liters, 10 liters. What happened to a biological organism when there's too much water? Can you imagine that? That yourself, ourselves, we are the rivers. Think about it anyway. All right, so try to put it in simple terms. We don't use ecological terms much in my videos. All right, now let's take a look at another environmental. So how to manage this particular environmental aspect, treated effluent, is to control the flow rate of discharge. How do you know which flow rate to control? Then we have to begin by identifying our river. How much more water can our existing natural rivers take in or assimilate before it gets imbalanced? So that is called the bioassimilative capacity of the river. We need to study that first before we say, okay, let's release industrial effluent. Oh, treat it, passing the permit. Wait, there is always an effect. When we study things 6:30, we don't study well. We got to study what is needed by the river first before discharging anything into it. And when the ecosystem gets unbalanced, all of us, we have a huge price to pay. Let's take a look anyway into the next environmental aspect, which is coagulant. Well, as competent person, I think you know better than I do. Some inorganic chemicals like ferric chloride, ferric sulfate, perhaps aluminum sulfate. Whereas there are also other types of synthetic polymers or flocculant aids, such as anionic coagulant, cationic coagulant, or polyelectrolyte polymers, which are often being used in industrial effluent treatment system, especially for the purpose of trapping or coagulating with all the inorganics or metal ions, or yeah, some other chemicals or even salts in water, and bring them down in and settle as sediments or sludges containing all these inorganics. Now, these coagulants, regardless of its origin, whether it is inorganics, which is normally from rock structures of our natural resources, uh, and also polymers, which are actually petrochemical based products. So these are all environmental aspects, and they come into this treatment system as input aspects. Therefore, when we look at them from the life cycle perspective as input, we go upstream of its life cycle, whereby, in other words, we are asking a question to them: where do you come from? So they come from natural resources, and the more demand for them means uh, the amount or the reservoir or the remaining natural resources gets much less and less. In other words, the popular term in environmental management system is the impact called natural resource depletion or resource depletion. That is one environmental impact. And when we do mining, we are actually damaging the rock structure of hills when we are blasting the rocks for all these metals or for all these inorganics or even salts or even minerals, and when to look and to get metals what you call coagulant like ferric chloride, or perhaps they are polymers coming from petrochemical plants which originate from the oil and gas industry, therefore also damaging those geological structure, which is where the fossil fuel is, the bedrock. If it's oil and gas, or if it is from crude oil. Otherwise, it could be mining on the surface of land. That is called mining, and the environmental impacts. You're leaving a trail of mining tails. And these are all damaged geological structure, which is not reversible until we do something good about that area. Okay, that is one environmental aspect input, which is coagulant. So in environmental management system, we are supposed to have a very good operational procedure how to use coagulants in industrial effluent treatment system. How to use, the word how is actually related or directly it directly means operational control, SOP, for the use of coagulant in industrial effluent treatment system. So as IETS operator or wastewater treatment plant operators, technician, engineers, we have got to use these environmental aspects of coagulants in a manner stipulated in the IETS manual in order not to introduce excess coagulant or insufficient coagulant. Remember, there is always a balance. You got to strike that balance. That stoichiometry could be a thin line of balance or could be a good range of balance. So you got to find out. In order to treat this water well and not having excessive use of coagulants, which would have an environmental impact of resource depletion, or less use of coagulant, which allow higher chemicals to be discharged out and causing water pollution. Okay, there need to be a balance. Nonetheless, this industrial effluent treatment system rather, is heavy on energy. All the pumps are electrical operated. If you have got diffuser blower for your huge aeration tank, these are power hungry devices, equipments, and it has got to pump air through nozzles to diffuse. The smaller the nozzle, the better for the what they call aeration tank, because better surface area volume ratio for the mixing of dissolved oxygen in the aeration tank. But on the other end, when the nozzle is smaller, more pressure is needed. In order for that pressure to build up, you need to have more power from the blower. The blower pump has got to pump harder, stronger, in order to have that well diffused bubbles of air in the aeration tank. And that's a lot of energy. On top of that, you've got control panels, you've got flow meters, you've got pumps, you've got vortex pumps, you've got positive pumps, you've got dosing pumps, etc., etc. And lightings, of course, for the control room. We got to work at night, right? In the night shifts. And these are all electrical energy. And if you are the CEO or the financial controller of this company, you'll be scratching your head from time to time, because all this energy gets into what is called industrial effluent treatment system, and money is used to pay for this energy, and there is no payback. There is no ROI. You know, if you're an accountant, you know this well. Return of investment is all about spending money in terms of electrical energy for this unit, and money is not coming back. That is why when I address a risk associated to RETS, it's all about energy consumption. Why? It's money. Of course, IETS has got this system has got its legal liability, where when we don't treat the water well, it doesn't meet the standard of the law, we can be penalized. But what I'm saying just now is about the energy consumption. If I'm the owner of this plant, I'll be scratching my head, because these are all money down the drain. So we should recover that money. What do I do? What would I do if I'm the CEO of this plant? I don't care what governance is saying, but I will deploy all means to ensure that energy that I used for something that doesn't return me in terms of payback to be renewable energy, such as wind turbines, vertical type wind turbines, such as solar power energy. Well, one-time investment is huge, but I get my returns in terms of cost saving over time. Okay, what else? Oh, a few other things. Okay, never mind. And there are other types of risk. There you are. We are, look, listen carefully. For our plant to use water in its manufacturing processes, we have to buy water from the Public Utility Board. We purchase water in terms of dollars and cents per meter cube. And after that water is being used, and we got our product, of course, we sell our product with a profit, but then there is something that some of the money flows down the drain in terms of treatment. We pay for this treatment to treat water that we paid for, and We treat that dirty water, clean it, and release cleaner water into the drain FOC. And we pay for the water, we pay for electrical bills, we pay for employing competent persons, we pay for chemicals, etc., maintenance, etc., etc. You know better than I do. And we are losing money all the time. What are we doing? That is why I would say, why not recycle this water? You know, why not? We are losing all these water resources. On top of that, I would suggest we do rainwater harvest from our rooftops. These are all risks. We are losing natural resources in the drain. What are we doing? Or what are we thinking? Okay, right. No offense, please. It's been things that that I get to sleep with sometime thinking about all this. So therefore, we have some opportunity over here. What is it? There you are. As I mentioned just now, this is environmental management system. This is what ISO 14001 version 2015 is talking about. If we understand the meaning of environmental aspects, if we understand the meaning of environmental aspect, which is anything that interact and can interact with the environment, you get to all this. So it's all interacting and we are using energy. So why not we cut that link of losses by having renewable energy program? And look, we dispose of cleaner water, treated effluent, cleaner water we dispose out into the drain and causing some imbalance, hydrological, the hydrology of the receiving streams and rivers. We cause imbalance of the water itself. They have additional water. Why not, instead of treating water and release it into the stream, take it back to our company, at least to channel back to our toilets? Today, as we live, we have to pay to do our business, especially in supermarkets. Even at home, we are paying for the water to do our business. What sense does it make? You know? So instead of releasing this water, recycle the water back to our toilets. Of course, we got to do some initial engineering and installation, one-time costs, and perhaps very cheap maintenance over time. And we get back our money. We reduce in the fresh water that we buy from the Public Utility Board to do our business, and also floor cleaning and other housekeeping for the factory uses water. On top of that, we tap rainwater harvest. Okay, and in the future, not to say in the future, I have already preached this since 1999, and some companies are doing it also, but despite the effort, there's some problems with the agencies over here, because I am looking into treating water, effluent, industrial effluent, using natural plants like duckweed, like water hyacinth, because we have studied mangrove plants. The mangrove roots are able to absorb a substantial number of heavy metals, and somebody is studying the mangrove leaves, which can be used as one of the membrane in a reverse osmosis technique. Okay, so we go back to nature. The nature is calling us to use them in a good manner, but we have destroyed nature. We have destroyed wetlands, mangroves, and well, it can be lengthy if you want to. If you let me talk about it, You wouldn't like to hear what I'm about to say, but never mind that. Just forget about it. Back to this one. So these are all the risks and opportunities with regards to the resources, with regards to industrial effluent treatment system operation and activity. What activity is this? Effluent treatment. So we have an environmental management system which is managing all these environmental aspects by fulfilling compliance obligation not only to authority, not only to government, but all around us, and also the ecology. That's our obligation, and addressing risk and opportunities. So that is ISO 14001. Slice of a cake, effluent treatment. Slice of a cake of the ISO 14001 environmental management system. One cross section of the EMS. So I hope you have understood what I've said, what I've shared. I'm still learning. Today I'm learning from younger people with regards to natural treatment. Some are doing it. All right, and I think that's about it for this video. I thank you for your attention. Thank you uh, for your subscription. Please subscribe and support me in my work. And to all the viewers and subscribers, thank you very much. And my utmost gratitude to the team in YouTube who have done a marvelous job. Okay, so I end this by wishing everybody in Bahasa Melayu, semoga dikurniakan kesenangan, keselamatan, kesejahteraan, kebahagiaan, dan kejayaan kehidupan di dunia dan di akhirat. I end this by wishing everybody, wherever you are, whoever you are, Assalamualaikum warahmatullahi wabarakatuh. See you in the next video, inshallah.